Alright, this section is 3.1 exponential functions. The essential question here is, what are exponential functions and how are they used? Be sure to pause this video anytime you need to take a second to either take some notes. Feel free to rewind if you need to see something again. And here we go. Alright, you've seen these before, but exponential functions are functions where the base is a number, in this case they just put b, and the exponent value right there, that's going to be our variable. B is always positive, and generally b is going to be somewhere between 0 and 1 or greater than 1, but not usually 1. So if you look at this first example here, the base is 2, and of course we're raised just to the x power. The second one, the base is 10. The third one, the base is 3, and the fourth one, the base is 1/2. Right, these are all examples of exponential functions. Okay, below, however, though, these are not exponential functions. Okay, so if you look at this first one, the base is x. It's not a number, so that doesn't qualify. And the second one, the base is 1. And 1 to any power is just 1, so that doesn't really satisfy the exponential function. In the third one, the base must be positive. And in the fourth one, it's just x to the x power, and both the base and both the exponent are variables. Okay, the first example here involves the exponential function f of x is equal to 42.2 times 1.56 to the power of x. This models the amount of money spent, which is f of x, in dollars, and at a shopping mall after x number of hours. What is the average amount spent to the nearest dollar after 4 hours? So here we're trying to find out what f of 4 is, because 4 represents the number of hours, so we take 42.2 times 1.56 and raise that to the fourth power. Take a minute to plug this into your calculator. When you plug this into your calculator, you get f of 4 is equal to 249.926. And because we're dealing with money, we're going to round this to 249.93. The second example here will be, we show you the graph of f of x is equal to 2 to the power of x. And then what I'd like to show you here is what they did is they created just a table of values here and then came up with the y values for each one of those values. What's really important to remember is 2 to the negative third power is the equivalent of 1 over 2 to the third power, and that's how they got the 1 over 8, and then the 1 over 4th for 2 to the negative second, and 1 over 2 for 2 to the negative first. And then they just took this and plotted each one of these individually. I'd like you to take a moment to plot both this table of values and this graph into your notebooks. Here now, I would like you to graph f of x is equal to 3 to the x on paper using a table of values. Pause the video, and then I'll show you the solution. Right, creating a table of values here. I just stayed very simple. I picked negative 3, negative 2, negative 1, 0, 1, 2, and 3, and came up with the corresponding y values very similarly to the last problem. So here you see each one of the points plotted for this function, and then if I just simply, it's going to look something like this. And then what I'd like to make sure that we all understand here is this goes forever in both the negative x direction and the positive x direction. So the domain here will be from negative infinity to positive infinity. And the range here is from 0 to infinity. And I want to point out here that the line y equals 0 is a horizontal asymptote. graphing g of x is equal to 1/2 raised to the x power can be done exactly the same. You could create a table of values with 1/2 raised to the x value for various different x's, but first what I'd like to show you is we can actually work with numbers that we like a little better. And we can do that by just kind of manipulating g of x a little bit. And what I'd like you to know is g of x is also equal to 2 to the negative first of x. So now this is actually equal to 2 to the negative x. So let's use this version of the function to create our table of values. So again, if I just pick -3, -2, -1, 0, 1, 2, and 3, very similarly to 2 to the x, I get here, because it's going to be 2 to the negative third, that's going to be equal to 8. This one is going to be equal to 4. -1 is going to be equal to 2. 0, of course, is going to be equal to 1. And then I have 1/2. Then I have 1/4. And I have 1/8. Okay, so it's actually the exact opposite of that. And when we graph this, we get, let me draw my axes, a graph that's similar, but flipped on the vertical axis. So at 3, I'm at 1/8, then I'm at 1/4, and then I'm at 1/2, and then I'm at 1, 2, and our graph is going to look something like this. So this is a very helpful graph of 4 different exponential functions. And what I'd like you to notice here is when they go from 0 up into infinity, you notice here that the two functions are 2 to the x and 7 to the x. And those are when the base is greater than 1, we have that sort of exponential increasing. When the base is between 0 and 1, if you look at here this blue graph and this kind of magenta graph, because the base is less than 1, we have exponential decreasing. So that's a nice way to keep those simple. So when it's greater than 1, exponential increase. When it's less than 1 but greater than 0, exponential decreasing. So there's a lot that's on this page right here, but what I really want to pay attention to here is number 1 says the domain of f of x, of all the exponential functions, is always going to be -infinity to +infinity. And for this type, the range is just going to be from 0 to infinity, meaning the horizontal asymptote is at 0 and then goes up into infinity, and it will never go below the x-axis in this instance. Okay, and again here, the y-intercept is always going to be 1 because anything to the 0 power is equal to 1. And then go ahead and read 3, 4, and 5, and 6, and then take any notes that you see that might be helpful to you here. Alright, this information is all on page 392 if you want to copy it down, but this helps us look at translations of any exponential function. So if you notice in this first set right here, the c right here, the plus c and the minus c are outside of this little base with the exponent. When that's the case, it's a vertical translation, and plus c shifts it upwards, negative c shifts it downwards. Okay. When the c is actually up with the exponent, it's a horizontal translation, where plus c shifts it left, negative c shifts it right. And then for the reflections, if the negative is in front, it flips it along the x-axis. If the negative is part of the exponent, it flips it over the y-axis. And then you have any vertical stretching or shrinking, and that's by if you have some number being multiplied, if it's larger than 1, it's a stretch, and if it's smaller than 1 but bigger than 0, it's a shrink. And then if you have horizontal shrinking or stretching, it's when you have, like, say, for example, if you have here, like, 2 to the 3x. that would be some sort of horizontal shrink there. Or if I have 2 to the 1/3 x, that would be a horizontal stretch. So example 4 asks us to take the f of x is equal to 3x and somehow use that to obtain the graph of g of x is equal to 3 to the x plus 1 power. So we're going to use the graph we came up with earlier. So here, this is the graph. The red is f of x is equal to 3 to the x power. Okay, and now we're going to be using this to sketch this. And then what I want to point out here is, remember, this plus 1 means shift 1 to the left. So every one of these single points right here, this one, this one, this one, this one, this one, this one, and this one, is going to go 1 unit this way. So in blue, this point is going to be right there. This point's going to be there, 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 and so forth. And when I draw my line, okay, so our blue graph is going to be g of x is equal to 3 to the x plus 1. And for our last example of this session, we're going to take the graph we had, which is 2 to the x power, and somehow make that into, or use the translation abilities to graph 2 to the x minus 3. Alright, so here is the graph of 2 to the power of x, and then for g of x, this means we're going to shift down 3 units. So I'm going to take every one of these values I have. So this is at positive 8, so that's going to drop down to positive 5. This second point at 4 is going to drop down to 1. At 2, it's going to drop down to negative 1. And at 1, it's going to drop down to negative 2. And all of them will be doing a similar drop of 3 units. So this blue line now is g of x is equal to 2 to the x power minus 3. So remember, when it's outside of the exponent, we shift it down or upwards, however many units that value is. Your homework for this section is on page 396, and do all of these problems, but be sure to stop at number 33. We'll do the rest of these next time.